Okay, the long-awaited applied maths paper has been put up. It was put up seemingly fairly early. Um, Yesterday it would have been. Yeah. Well, no, sorry, today. What am I thinking? It was put up really early today. It wasn't up actually the entirety of yesterday. So my thoughts on it: yeah, some good bits, some bad bits. Okay, give me 100 quid for my review. No, I'm kidding. No, that's what the Institute reviewed it as. Essentially, it was some easy bits, some hard bits, bleh, and didn't really address a major part of the exam paper, which I'll get to in due course. Um, but for now, we'll just begin with the question one, as always. Uh, Minimum spanning tree algorithm, fairly okay. It didn't specify cruscals or prims this time, which I think is a much better idea. Some students prefer cruscals, others prefer prims. That's entirely up to themselves. Then a Dijkstra's algorithm question, two algorithms in the same question is a bit much because they do take quite a long time to do. So having two in the one question, especially as question one, might have taken people by surprise. And then there was another part, and then the first of, we'll see, four difference equations in the entire um, part of the exam. Though this one wasn't too bad, you just had to find U1 and U2, and then weirdly enough, showing that something is a solution rather than coming up with the solution ourselves, which is fairly okay. I know a lot of books don't mention first order inhomogeneous, so you could have actually subbed this in or done the method for first order inhomogeneous. At least we know that they're specifically brought up in an exam question, so that's okay. Question two, another networky type question, though this one was pretty okay, just taking activities from a dependency table. I threw a lot of these in, excuse me, my most recent mock papers, just because obviously it hasn't been asked in this way in quite a while. From what I remember, I think there was one in, excuse me, I think there was one in 2023, though I could be misremembering. So this was one thing I was, sort of urging my students to look at. Just ask you to draw the network in here, so not actually too bad. And then this question involving the moving of a fan, which is a bit of a unique, or sorry, not the moving of a fan, but a fan moving an object. Excuse me. So this one wasn't actually too bad. Did require a little bit of thought in terms of the forces acting on the 4 kilogram mass, especially with this, the force decreasing by 12 newtons per meter. Though I can't actually remember off the top of my head. I think it was 2010. It was definitely one of the earlier papers in the 21st century, at least, that mentioned something similar to this. I think it was something hanging from a string, and the force was modeled that way. So if you look back at previous differential equations, you would have seen this, and the force setup would have been pretty okay, which would then lead you to, again, the first of four differential equations. Though this one was a lot easier, multiply by dx and integrate both sides, given the bits of information. Yeah, it's pretty okay. This is actually just forming it, and the next part is solving it. And then a fairly okay question, just extending from the differential equation. Question three, initially a fairly okay pulleys question, just involving two masses, but then you have a ring C, which incorporates conservation of linear momentum. Now, this is a very, very small section in a lot of the textbooks, mine included. It only actually spans 3 pages, but the comparison, oblique collision spans ahead 20. So this is a really, really small part of the course, so it's interesting they brought it up. Though in fairness, it's only actually here for 3 parts. So you have the forces on both A and B, which is fairly okay. I'd say most of the marks would go for this because it's 2 particles, so it must be 10 out of the 50. Acceleration and velocity, they're pretty standard follow-up questions for pulley systems. And then we have the 2 small bits involving the conservation of linear momentum. Though I'd say the amount of space they give you is really inconsistent. Like, they give you 1.5 pages for just part V, which I think is a little bit excessive. Like, the amount that they have space-wise for questions is, a tiny bit debatable in terms of the length that some questions will take, though this one should not have taken you 1.5 pages. This one was actually fairly okay. Question 4, nice direct collisions question. A fairly standard setup, should have no bother with questions like this. And then impulse being brought up. I know a lot of students have issues with, the sort of signage of the impulse. Though in this case, seemingly, like, for the fact that the mass is clearly positive, this is taken to be just the magnitude. And I definitely would have worked with the magnitude of the impulse in this case, so I wouldn't have worried about the signage or anything. And then we have possibly one of the nicest direct collision, or not direct one, Jesus Christ, oblique collisions, there we go. One of the nicest oblique questions of all time. Giving you the velocities in vector form, asking you for the speed, absolutely no bother. Then asking a deflected angle, so you just take, was that for B1? So you just take the angle it came initially and then find the difference between it and the rebended angle, whatever way that goes. So I know a lot of students avoided collisions, but I definitely think this year it was a bit unlucky because these were fairly basic collisions questions, both direct and oblique collisions. Question 5, again, pretty bog standard circular motion question. We were expecting a slightly more standard circular motion question this time around because the one from last year was a little bit strange, so this one's a lot more straightforward. Asking you for a force diagram and then talking about a reaction force. And then disconnecting, or the particle disconnecting from the table. And then a vertical circular motion question also came up in here. So they're seemingly sticking to topics wherever possible. Like this entire thing was on circular, the previous question was entirely on collisions, which I do think is nice. Because if you struggle with a whole topic, you can skip a whole question rather than only missing a part of it. Circular motion being one that I know students have a bit of a gripe with in terms of its difficulty, but this vertical circular motion question was not too bad once you actually got down into the maths. Question 6, the second differential equation. This is not the one with the big issue. The one with the big issue comes later. Though this is a fairly okay motion question. Divide through by the 3v squared plus 4 and you get a fractional integral that you can solve from there. Basically two entire pages is a little bit too much because this could be done in about a page, but again, I don't make the pages. And then, at first glance, this is a seemingly pretty tough linear motion question. Though again, when you actually sat down and did the maths, you will find that this one is pretty okay and not the worst linear motion question, because there have been some linear motion questions, 2024 question 1C, just to give an example, that were really, really mean, though this one was fairly tame. Again, 2 pages is way too much. Okay, now we have a combination difference and differential equation question, starting with a first order difference equation. Just subbing in here, getting this equation, and then solving the difference equation. Pretty straightforward using whatever method you like. Whether it be the one from the Oliver Murphy or the far superior method on JT Maths' channel, which I do highly recommend. And then just testing the model. So that's actually okay. And then the differential equation, again, you're going to get some logarithmic differentiation coming up here. You'll get a log popping up and then obviously an exponential if you're rearranging big T for little t. Though what's weird about this one is that you sort of weren't asked to evaluate the model, which I felt was a bit strange. It didn't necessarily ask you compare the difference equation to the differential equation in terms of, say, the long-term behavior of the caramel. Yeah. Which I think is a bit strange because it seemed like a perfect question to include, like even chopping this halfway and saying by comparing little t equals to 10 for both models, evaluate which one is better, blah, blah, blah. Considering the whole course is about modeling scenarios, I thought that would have been a pretty appropriate question, but that wasn't meant to be. Now, if there's one combination of questions I was not expecting, and that was definitely not on my bingo cards, it's linear motion with difference equations. Now, granted, you could treat this like a function s of n rather than s sub n, but it gives off strong difference equations just in the format. Yeah. We had to derive a difference equation. So, not one on the bingo cards, but a full question on difference equations nonetheless, with that tiny bit of linear motion thrown in there for whatever reason. Though this second order inhomogeneous difference equation, absolutely beautiful. I had no issues with this one whatsoever. Two fairly okay parts. It was really short, but again, the second order inhomogeneous does take up a long time, especially because you have to generate the test function. Solving a characteristic, putting them together can often get a bit messy. But no, this one I'm pretty happy with. This is the one that confused students, and when I was reading news articles about this, this was one of the points that I saw and I thought, really? The SEC left this in? So again, we have another motion differential equation, which is a bit odd, having two of them in the same question. However, when you did this over and integrated, no matter what you did in terms of if you differentiated the log correctly, that got you the whatever it is, t squared times 1 over t. You know, the log would have still been left to evaluate. So I'm doing this incorrectly, but just kind of a vague thing. U is log 2t, so u prime is 1 over t, and t squared is v prime, so integrating that is t cubed over 3. You'll get u times v, so you'll get log 2t times t cubed over 3, just like in this instance. However, when you go to evaluate the bounds, you realize that you're taking natural log of 0, which any calculator will tell you is not defined. So I'm not sure what happened in the SEC department when this question was being made. It's probably just a silly mistake. You know, it might have been, say, t equal to 1. You know, if t was 1, that would have been okay. I think what happened was that when they were carrying out the integration by parts, this t cubed over 3 log of 2t might have just been left to the wayside. And then this other thing would have been integrated fine. It probably would have got a 1/3 t squared somewhere in there. I haven't actually done out this particular paper, that's why I'm just guessing the answer. But I'd say when they were forming the initial equation and the log disappeared in the integral, this was not seen as a problem. Though, of course, when you're integrating, you need to evaluate all functions which are present in the final integral result. So because this occurs so early on in the question, my thought is that the question is going to be given full marks to anyone who did some sort of attempt with separating the variables. So it looked like a pretty horrific question. However, in slight hindsight, this bit of information, keen-eyed students would have been like, oh, right, cool, easy marks, just for doing nothing, maybe separating the variables. And subsequently, this question here might have been slightly broken, though you could have easily used this result, because it gives you S in terms of t. So, bit of an odd question. I really have to say, I'm not sure how that slipped through the cracks, but I guess it's free marks to anyone who answered it with some degree of certainty. In terms of marks, by the way, I'd probably say that this is 25 or possibly 20. It probably splits to 20 and 10, making 30. And then this projectiles question, by the way, is absolutely lovely. Setting up a velocity in terms of I and j, and then a displacement in terms of I and j, and then using the dot product, or setting the dot product to 0. Apologies. So yeah, you set the dot product equals 0 and you get this result. So I'd say that wasn't worth too many marks. I'm not sure what the SEC is going to do about this error, but it is a case of wait and see. Again, an educated guess would be if you did some decent attempt at it, you'll get full marks. Okay, and then question 10, another activities-based question. This time you actually have to fill in the activity network, though this is a lot of text that you can pretty much just completely ignore. You just have to fill in the early and the late times, and then finding the critical path. So 2, again, questions you would have seen time and time again with activity networks, both in previous exam papers and in most textbooks. And then a Gantt chart appears again, not necessarily specified on the course, but has appeared in exams so much, we're just kind of like, we might as well just have this. I had it in my notes since day one, but I know a lot of other books. I think the Oliver Murphy one does it, but I know some resources actually don't include Gantt charts, which is a bit strange. And then some effects on, part 5 is an effect on a delayed activity. And then the minimum number of workers, which you do the total time for all activities over the critical time. Though you'll obviously have to look at it through the Gantt chart, just seeing how many different rows you had. But the theoretical minimum is the critical time. Sorry, total time over critical time. And that's the end of it. So, my thoughts on the paper. If you didn't know differential or difference equations, then you were pretty screwed in terms of a lot of the questions on here. There's an entire question on difference equations, and we've seen now that pretty much 40% of the questions had a differential equation in there somewhere. So, differential equations were pretty prevalent on the previous papers, not necessarily in the 2023 paper, but they've definitely made more regular appearances in these slightly more modern papers. So, I recommend for any of the cohort, studying applied maths next year, to really hone in on the integration techniques and solving difference equations. Because, if they have that sort of concentration in the exam, then it's best to have that pretty easy upper hand. So obviously I know I'm a bit late to this and not many people want to see this review. That's entirely okay. The Leaving Cert is finally over. We can enjoy the absolutely insane weather we've been having. Yeah, that's it for the 2026 exam season.